Hi, my name is Keiru Desai and I'm with the Cisco Wireless Stack. In this session, I will talk about designing a voice over wireless LAN on a Cisco controller. The session is meant to provide a high-level view on design and configuration requirements without getting into too many details. The voice over wireless LAN topic is an extensive topic and actually we can spend hours discussing the details. However, by the end of the session, you should be able to configure your Cisco wireless controller, a 7921 or a 7925 phone, and your wired network to be voice over wireless LAN ready. The approach taken here is to hit the highlights, beginning with the RF requirements, followed by the phone and the controller configuration. So let's get started. Compared to a data network which can handle packet loss and some delay, voice is sensitive to packet loss caused by coverage gaps and jitter or delay caused by QoS misconfigurations. As a result, it is critical to design your wireless with sufficient coverage and capacity. To achieve this, a pre and post deployment site survey is absolutely critical. While doing a site survey, you need to consider the following guidelines. We are looking for a coverage overlap of at least 20% between two access points. Check that the phone always maintains an RSSI of negative 67 dBm or better, and in terms of SNR, a value of 25 dB or higher. Ensure the co-channel interference, that is the access points operating on the same channel, is low. It should be typically below negative 86 dBm or lower. In a high density environment, it is recommended to use 802.11a due to the number of non-overlapping channels that are available. Another big advantage of the 11a band is that it operates in the 5 GHz range, which is not susceptible to interference from Bluetooth and microwave. The next two slides talk about designing an 802.11a based voice over wireless LAN network. In the 802.11a band, we have the Uniband 1, Uniband 2, and Uniband 3, each providing 4 channels. Besides this, we also have the extended Uni2 band, which provides additional 8 channels. In all, in the US, you can get up to 20 channels in the 5 GHz range. In terms of capacity, assuming that the phones associate at the minimum allowed data rate of 12 megabits per second, you can have up to 20 RTP streams on a single access point. In a high density environment, where we have the phones associating at 24 megabits per second, you can have up to 27 RTP streams. Now these are only ballpark figures, as the overall capacity depends on co-channel interference, the number of SSIDs being broadcasted, and the overall noise floor. Here is a sample view for a high capacity voice over wireless LAN deployment. This is not a recommendation, but just an example for supporting high capacity voice traffic. As I mentioned earlier, site survey is absolutely critical for a successful voice over wireless LAN deployment, and due diligence prior to installation will prevent a lot of issues related to RF. On a Cisco wireless controller, it is recommended to use the RRM algorithm or the radio resource management algorithm for channel selection. However, if you plan to manually assign channels to access points, it is recommended that the adjacent channels should not be placed close to each other as they are overlapping. So in this example, as you look at the band on the right hand side, channel 36 and channel 40 are overlapping and hence should not be placed next to each other. If you are planning to assign channels manually, you should assign channel 36 followed by channel 44. This completes the RF basics, and now let's look at the phone configurations. Having looked at the basic RF requirements, now let's look at the phone configuration. The phone configuration involves two aspects. One is the wireless mode selection, and the other is security settings, which is just like any other client configuration. Now there are different methods to configure the phone. You can use the manual keypad to configure an individual phone, or you can also use the browser option and log into the phone. I have listed here the default configuration on a phone, which can help you get the phone configured for your SSID. In the wireless mode selection, we have the 802.11a, 802.11bg, Auto A, and Auto BG. What this basically means is with an Auto A setup, which is the default setup, the phone will prefer 802.11a throughout the network.
It'll switch to BG only when it is out of coverage in the 802.11a network. The same goes with the auto BG, where the phone would prefer BG over 11A. The final option is the receive signal strength, where the phone will select the AP and the band with the strongest signal. Now the roaming algorithm sort of varies based on the mode that's been selected here. However, the preferred option is either to use Auto-A if you plan to use both the bands, like the 2.4 and the 5 GHz, or just use 802.11a. Now let's look at the security options. The phone can be configured for pretty much all sorts of configuration options as shown here in this table. You can have an open SSID, which is rarely used, but to all the way to EAP TLS, which is the strongest security option. The most popular ones are EAP Fast, PEEP, which provide good enough security and also a good roaming experience. In terms of the encryption that is used, that is post-authentication, the point to be noted here is the phone version. On the older phone versions prior to 1.3.4, AES was not supported. But going forward in the newer releases, in fact any release beyond 1.3.4, AES encryption is supported. So you could have WPA with TKIP and WPA2 with AES encryption. One of the interesting options that is listed here is the AKM, which is the Authenticated Key Management. Now the AKM uses actually LEAP if you plan to use 802.1x, or it uses WPA PSK or WPA2 PSK. So depending upon the information that is set up in the phone, with AKM setting, it'll either use LEAP authentication or the pre-shared key. Here are some snapshots of configuring the phone with the security options. So on the drop-down menu, if you plan to use the browser option, you will see all the options listed in the previous slide. If you plan to select PEEP, you would select PEEP. If you plan to select a pre-shared key, you would use something called as AKM, and then you can enter your pre-shared key.
If you plan to use EAP TLS, you have the option of using manufacturer install certificate or your own device certificate from your certificate authority. In case of using PEEP, if you select the option to validate the server certificate, you need to install the root CA certificate from your server certificate vendor. At the IP layer, as part of the DHCP process, ensure that you have the DHCP option 150 configured. The DHCP option 150 is used by the phone to register to the call manager. Also ensure that you're running the latest firmware on the phone. At the time of this recording, the latest firmware is 1.4.2. Finally, from a roaming perspective, it is recommended to use 802.1x base security with CCKM encryption, as it provides the best roaming experience even when compared to a PSK-based authentication. I will briefly talk about CCKM in the next slide.
One of the critical components in a voice over wireless LAN deployment is the roaming aspect, and that's where the Cisco centralized key management comes in. CCKM is a Cisco proprietary algorithm which enables fast roaming. CCKM uses different keying methods to enable fast roaming between access points. On the left hand side you see a regular .1x based authentication where you notice a reassociation to an access point results and reauthentication with the radius server followed by what is called as a four-way handshake process. Once the four-way handshake process is completed, you see the phone resuming the voice conversation. Now when you compare that to the right, which uses the CCKM, the design minimizes the number of packets that are exchanged between the phone and the access point before the voice is resumed. Now in the interest of time, I have just provided a very simplified explanation of CCKM. However, the main takeaway here is that the use of CCKM provides a very positive experience in terms of roaming. If you look at the top right hand side, you see the different roaming times when different authentication methods are being used. You see that the CCKM provides even better performance than the WPA2 PSK, which at times I've seen the customers find it very counterintuitive. But this is the whole reason behind it. The number of packets exchanged between the phone and the access point with the use of CCKM is reduced drastically. Now, WPA PSK is also a fairly decent option. So if you do not have an option of using 802.1x, WPA2 PSK with AES or WPA PSK with TK will also provide you a pretty good roaming experience. Okay, now let's switch gears and look at the wireless controller configuration to make it voice over wireless LAN ready. We will hit the highlights, talking about the data rates, how to configure the WLAN SSID, and some other basic requirements to meet the voice over wireless LAN design guide. So let's get started. So I have a wireless controller here in the lab, running 70220. It's a 5508 controller, and we will create now a voice over wireless LAN ready network. So let's create an SSID. I'm going to create it called key voice. So here are the main decision points. So first is radio policy. If you plan to broadcast the SSID only on the 802.11a, would be selecting this. However, if you choose to select broadcast the SSID on all the bands and all the protocols, you would select all. The interface would be the VLAN on which the phones would be getting their IP addresses from. So you could have it set up for management or whatever your design is set up for. Under security, I'm gonna run an example for PEEP-based authentication. So if you have the newer phone version code, then you can use WPA2 with AES. With the older phones, you might want to use WPA with TKIP. And here, another decision point is the authentication key management. Now, to use the CCKM, as I mentioned previously in some slides, you have two options. One is to use the CCKM, and the other one is 802.1x plus CCKM. The difference between the two is when you use 802.1x plus CCKM, other non-phone or non-CCKM clients will be able to connect and associate to this network. However, if you plan to design this SSID only for voice, then the recommended option is CCKM. Assuming you're not doing any web auth, you would be using nothing over here. Under AAA, if you're using an external radius server, you would be pointing it over here to map it to the primary radius server. Under QoS tab, of course, since we are designing a voice over wireless LAN SSID, we would be selecting Platinum Voice. You gotta make sure that you do not have multiple SSIDs configured with the same QoS policies, otherwise it sort of defeats the purpose. If all the SSIDs are been tagged as Platinum Voice, then it sort of defeats the whole idea behind the QoS. For the WMM policies, since the 7921s and 25 phones do support WMM, you can set it up for allowed or required. And the final tab is the advanced tab. You gotta ensure that the enable session timeout is set up for a higher value. Right, the default is 30 minutes. So since you do not want the phone to disconnect in the middle of a call, you can either increase it or disable it, which would bring the session timeout to 24 hours. Ensure that the AeroNet IE is enabled, and P2P blocking is set up for disabled option. You don't want it to be dropped to be a dropped option to avoid phone calls on the same AP to be blocked. Also ensure that a DHCP address assignment is unchecked so that the phone does not have to do a DHCP every time it roams. The MFP client protection setting should be set up for optional or disabled. For DTIM period, the recommended setting is 2. The DTIM period is increased to improve the battery performance of these phones. The Cisco Unified 7921 phone can use the DTIM period to schedule a wake-up period to check for broadcast and multicast packets, as well as unicast packets. So with a DTIM period of 2, the phone wakes up every 2 beacons to look for multicast and broadcast traffic. Client load balancing is recommended to be turned off, as well as client band select. These two options are to prevent the clients or the phones from having any delays while roaming to another access point. This completes the WLAN configuration. Having configured the wireless SSID, now let's look at the wireless tab. The changes that we will be making here are network impacting, so do not do this during production hours. So under the 802.11a network tab, we would first ensure that the lower data rates are disabled. You gotta keep the 12 megabits per second mandatory, and the higher data rates can be kept as supported or disabled as well. Ideally, since you'll have multiple SSIDs, you can leave the other data rates to be supported. Ensure that the CCX location measurement is enabled as well as the client link. Ensure that the DTPC is also enabled, which will allow the phone and the AP to negotiate the power levels at which the phone will be operating on. Going down the 11A options, we look at the transmit power control TPC. Now in most cases you want to leave this as the default settings, but these can be also altered based on your RF environment, and a lot of these values will be dictated based on the site survey results as well. But in this example I'm going to leave it as default. Going further down with DCA, ensure that the DCA channel sensitivity is set up to low, which implies that the channels will not change on these access points unless there is some major interference. So you're just changing it from a channel sensitivity of 15 dB to 20. Also ensure that channel 165 is not part of the channel assignment, since the phone does not support channel 165. You also have an option of using the extended Genie 2 band channel. By enabling the extended Genie 2 band, we get additional 8 channels from channel 100 to channel 140. Now these additional 8 channels can be used in your RF channel assignment. However, the flip side is now the phone has to scan through several more channels to identify access points in the vicinity. In our deployment guide, we recommend that if you plan to use the extended Uni2 band channel, disable the Uni2 band, which is channel 52, 56, 60, and 64. However, this is a design consideration and it can change from case to case. The next important tab is the Media tab. Here you need to ensure that the call admission control CAC is enabled. CAC ensures that there is sufficient bandwidth available on an access point before a call is allowed to be made. The recommended CAC method for a 7921 and a 7925 phone is the load-based CAC. Without getting into too many details, the load-based CAC captures the real-time channel utilization of an access point, and depending on that, it makes a decision on whether or not to allow a new call or a roaming call. So please ensure that you have the load-based CAC enabled for 7921 and 7925 phones. Another cool feature on the controller is the traffic stream matrix. Since the Cisco phone is a CCX version 4 certified, they relay important information regarding the quality of the voice, like packet loss and delay every 5 seconds. And this is for upstream as well as downstream. The AP collects this information and creates a report for every 90 seconds of audio. Hence, while troubleshooting, the TSM reports can be really helpful to isolate the issue of voice quality related to RF environment. The next setting is the ADC Profile. ADC stands for Enhanced Distributed Channel Access and is part of the WMM specs. The recommendation here is to configure the ADCA for voice optimization. This setting changes the contention window timers for different queues, and by doing so, we provide the phones a better chance of accessing the wireless medium, thereby providing a better QoS performance. Hence, it's highly recommended to have the ADCA profile to be set up for voice optimized. Under the DFS 802.11h, make sure you have the power constraint unchecked, since we would be using the DTPC algorithm for the client and the access point to negotiate the best power levels. Channel switch announcement, you can enable this if you plan to use any of the channels which are in the radar band. So what this does is when an AP has to change its channel, it'll make an announcement and let all its client know about the channel being changed to, and also provide them the amount of time it's going to take for it to move to that channel. So it's always a good idea to have the channel switch announcement enabled, but you can leave the power constraint disabled
since we do not use that feature.
Last but not the least, we need to configure the Platinum QoS profile on the controller. Now, as the voice packets move across wireless and the wired medium, the QoS profile of the packets need to be maintained. There is a direct relationship between 802.11e user priority and the 802.1p and the DHCP value in the wired world. The explanation of this concept is beyond the scope of this video, but the bottom line is that this setting ensures that the voice packets maintain their QoS profile as it travels through wireless and the wired network. So you got to make sure that you have the 802.1p checked with the 802.1p tag set to 6. Once you do this, you are set up with your QoS profiles. This completes the controller configuration. Now if you plan to use the 802.11bg band, you would do the same configurations under the 802.11bg band. Now on the wired side, ensure that the access point switch port is set up in access mode and you have the MLS QoS trust DHCP statement in there. On the controller side, you can set it up on a trunk port and have the MLS QoS trust cost statement. Besides this, from a multiple controller configuration point of view, ensure that you have virtual IP address consistent across all the controllers, and all the controllers should be in each other's mobility group. Also, if you plan to use mobility multicast, ensure that multicast is enabled on the router as well as PIM is enabled on the management interface. Another thing that I've seen in a multiple controller environment, which breaks the roaming aspect between controllers, is the DHCP proxy settings. So ensure that this is also consistent across all the controllers. So we covered a lot of things in this presentation, and a good checkpoint would be to use this voice over wireless LAN troubleshooting checklist. I would recommend strongly to go through this checklist before going live on your voice over wireless LAN deployment, because it sort of covers all the topics that I've sort of talked about on this presentation, as well as some other details as well. I hope this session was informative for you, and I'd like to thank you for your time. And thank you for choosing Cisco.